Okay, this is part two of my word problem videos. So let's just continue here. This says Joe wants to cut a 53-inch board into three pieces, a short piece, a long piece, and one in between. He wants the middle piece to be 6 inches longer than the shortest piece, and he wants the shortest piece to be 11 inches less than the longest piece. How long is each piece? So, consistent with what I've been saying in the other video, first thing, just do a quick read through of the problem. Don't be too detailed yet. There will be time to think about that later. Just do a fast read and then concentrate especially on what we're being asked to do. How long is each piece? So the first thing we're going to do is assign variables. That's pretty standard in word problems. Assign your variables, and that gives you a standard procedure where you can logically continue from there and be getting something meaningful done. So I'm going to call X something. I don't know yet which thing I'm going to call it. We're going to have three answers here. So we're going to need variable expressions for three different lengths here. How long is each piece? Well, okay, I need to decide which one I'm going to call X, the long piece, the medium piece, or the short piece. And there's not just one way to do it, as I've said in the other video, but I tend to look for the thing that has the least description, that the least is said about, and I like to call that X. That's just me personally. So the three pieces, which one has the least said about it? He wants the middle piece to be 6 inches longer than the shortest piece. So that gives some description about the middle piece. So I'm not going to use that for X. He wants the shortest piece to be 11 inches less than the longest piece. Well, so that describes the shortest piece. I'm not going to use X for that either. Which piece does it say the least about? Well, that would be the longest piece. It doesn't give us any description of what the longest piece is doing. So I'm going to call X the length of the longest piece. Could I have made X one of the other ones, the medium or the short piece? Yes, I absolutely could have. This is just my preference. But basically, once you have a name assigned to one of the pieces, then you look at how the other ones compare and you change your variable expression accordingly. So we need something for, we need an expression for the shortest piece, and we need an expression for I'll call it the middle piece. Well, now it's a matter of carefully reading and seeing how the different lengths compare. I'm going to work backwards here. I'm going to go where it says the longest piece because I have already named the longest piece. So I'm going to kind of work backwards here. It says he wants the shortest piece to be 11 inches less than the longest piece. That means this right here, the shortest piece, is 11 less than this. How do I describe 11 less than X? Well, that would be X minus 11. So now I have an expression for the shortest piece that's consistent with the whole story so far. Okay, what about the middle piece? So it says he wants the middle piece to be 6 inches longer than the shortest piece. So that means the middle piece is 6 inches longer than this. So I'll just take this, that's the length of the shortest piece, and I'll add 6 to it. And now I have an accurate expression that fits the story for the longest piece, the shortest piece, and the middle piece. And now I need to make an equation. There always has to be a way to make an equation or you can't do any math. Well, it says the board is 53 inches long. That means that this plus this plus this must be 53. If I add them all up, if I take the longest piece plus, and the shortest piece is X minus 11, plus the middle piece. The middle piece is X minus 11 plus 6. So I've just basically totaled all of these up, and I know I'm supposed to get 53 when I do that. So you could sort of think of it as, let's see, let me come down here. Let's draw the board. Sometimes it helps to draw yourself a picture. So let's have a short piece, and then a piece that's longer, and then a longest piece. And basically we said that the shortest piece would be x minus 11. The middle piece would be x minus 11 plus 6. And the longest piece would be x. So that's what we're doing. And the whole thing is 53 inches long. Okay, well now we have our equation. So now's the kind of relatively easier part. Well, if I have x plus x plus x, that's the same as 3x. If I have 6 minus 11, that's negative 16. So I just cleaned up this side is all I did. I just combined all the x terms and I combined the constant terms. Okay, well now I need to add 16 to both sides. And I get 3x equals 53, 69. And then I need to divide both sides by 3. And I get that x is 23. So I can come up here and say that the longest piece is going to be 23 inches. Okay, well here I need to take the 23 minus 11, and so that's going to be 12 inches. Okay, since we now know that x is 23, just put it in each of these. 23 minus 11, 12. Okay, what's 23 minus 11 plus 6? And that is going to be 18. And so now if you were taking a test, you could just, test all these. Do they add up to 53? Do all the descriptions fit? Is, for instance, the middle piece 6 inches longer than the shortest piece? And so on. Everything it says, and you could very easily test that. Now, just real quickly, think about this. The way I did it was not the only way. So just real quickly, and I'm not going to elaborate, I just want to show you, okay, we could have said, I could have made x the shortest piece. And that would mean that for okay, and I'll let you, sit and think it out if you want to, but that would mean I would have to change the variable expressions from x to these. Okay, and so again, I'm not going to elaborate, but in that case, I'm just showing you it doesn't have to be the same as these. As long as you're consistent with the story, you could have called x the longest piece, the shortest piece, the middle piece, as long as you adjust it accordingly, according to the instructions of how the other pieces had to compare in length. And if you did this and you made an equation equaling 53 and added them all up, you would have gotten these same numbers. So don't think that what I'm saying about assigning the simplest variable expression to the thing that has the least said about it is the only way to do it. It's just my preference. Next we have a problem that concerns angles and an angle and its complement. So we need to talk about what complementary angles are. So complementary angles add to 90 degrees. So 60 and 90 are complementary angles, 45 and 45 are complementary angles, and, oh, I'm sorry, 60 and 30 I meant. 60 and 30, because they total 90. Any two angles that add to 90 degrees, a right angle, are called complementary angles. And the memory aid I use to remember complementary from supplementary, and supplementary we'll talk about shortly, but they add to 180 degrees. I use the saying, it's right to give someone a compliment. Well, a right angle is 90 degrees, so I just remember that, okay, right angle. Right angle. So it's right to give someone a compliment. So this is talking about an angle and its complement. So I'm immediately going to say, okay, I'm going to call x the measure of that angle. We don't know how many degrees it is yet, but we're going to call it x. And it says find the measure of an angle whose complement is 5 times its measure. Well, so what would be, according to them, the complement to this angle? They would both be complements of each other. But the original angle is going to have a complement that it says it's 5 times its measure. So that's a key thing there. So how are we going to make an expression in light of this angle that would accurately reflect the story? Well, it says the complement is equal to 5 times, let me use the same color here, 5 times. Well, this accurately reflects what the story says. If the original angle is x, the complement is 5 times the amount of x. And how are we going to make an equation? Well, by definition, these angles must add up to 90 because it says they are complementary angles. And there's our equation. That's all there is to this one. So I got to combine my x terms. If I have 1x plus 5x's, that's 6x's. And now to know what x is, the measure of x, I have to get it alone. X is some number that was multiplied by 6. I don't want it to be multiplied by 6, so I have to undo that with the opposite, which means I have to do the same to this side. And now we get that x equals 15 degrees. And so we now know that the angle we're talking about is 15 degrees. Now notice it only asks for the measure of the original angle, but sometimes it might say give the measure of the angle in its complement. So if you were asked to do that, then you would simply say, well, now that I know that x is 15, I just do 5 times 15, and I know that the other angle is 75. So even though they're not asking for that here, I just want to make the point that sometimes you need to give all the answers. Sometimes they only want one of the two or one of the three or whatever. Let's do another one here. This one is also constraining angles. This is the measure of the supplement of angle A is 40 degrees larger than twice the measure of the complement of angle A. What is the measure of angle A? So again, we just read over it quickly and then we go straight to the question part. And we're going to assign that a variable. So I'm going to say x is the, well, actually, we'll just understand. So I say time. I'm not going to write the measure of angle A. I'm just going to write angle A. But we understand it's the measure of angle A. Okay, so that's the first thing I'm going to do is assign my variables just like we're supposed to do. Now, this is kind of a wordy problem here that, sometimes you just need to kind of sit and meditate on and think about what are they saying. But one thing you'll notice here, we are going to need the supplement of angle A and we're going to need the complement of angle A. So those are two things to definitely take into account. Over here, I've written the complement of two angles. It's always two angles. Two complementary angles are two angles that add to 90 degrees. So that could be 45 and 45, 60 and 90, 80 and 10. Supplementary angles do the same thing, except they add to 180 degrees. And so what I'm going to need to do here is I need to take angle A, which is x, the measure of angle A, and I need to come up with something that will reflect the complement and the supplement. Okay, so if we're calling x the measure of angle A, what expression would accurately reflect the angle that is the complement of A? This would be an angle that you add to x and you would get 90. So let's just, I think down here off to the side, let's take, okay, so x plus, I'm going to put c for its complement. We know they have to add to 90. And so the complement, if I subtract x from both sides, I get that we could express the complement as 90 minus x. So that's what we're going to do. If the measure of angle A is x, then its complement would be 90 minus x. And you could try that. What if angle A was 10? Well, then 90 minus 10 would be 80. That would give us two complementary angles, two angles that add up to 90. What if we make x 45? So this is 45, 90 minus 45 is 45. That would give us 45 and 45. So this expression works. This always gives us an angle that would be the complement to this angle. Okay, and we could do the same thing with the supplement. The supplement, okay, so if we take angle x and we're looking for, I'll use S for supplement, we know that by definition the original angle plus its supplement have to add up to 180. If I subtract x from both sides, then we see that an accurate expression for the supplement would be 180 minus x. So we're going to say 180 minus x. So here I have the original angle. Here's the expression of its complement. Here's the expression of its supplement. We should have all the pieces we need here to do what they want us to do. Okay, it says the measure of the supplement of angle A is, okay, so let's just look at that part. The measure of the supplement of angle A is, well, that's an equal sign there. So that means we're going to put the supplement on one side. Well, the supplement is this thing right here. So we're going to say 180 minus x. It says that is the same as 40 degrees larger than twice the measure of the complement. Okay, that has to go on the other side. So we need to think, carefully how to parse this out. 40 degrees larger than twice. Well, I'm going to do twice the measure of the complement first. That means I'm going to have to do 2 times, this is the complement here. It's going to have to be 2 of these. If I take 2 times the complement, so I'm doing what they're saying, I did twice the measure of the complement, and then it says 40 degrees larger though. That means I have to add 40 to this. And I've done what they said. I formed a complement of A, I formed a supplement of A, and then I did everything they said. And so now this is math speak, math language for the English that we see up here. Now the only thing I have to do is solve this. So I need to distribute here. 2 times 90, and then 2 times negative x is going to be negative 2x. Okay. Now one thing that's easy here is I see if I subtract 180 from both sides, these just turn into 0. They just go away. So that's nice. So now I have it whittled down to just this. Okay, well now I need to get the x terms together, so I need to add 2x to both sides. Well, what's 2x minus 2x? You could either say negative 2x plus 2x or 2x minus 2x. I like to think of the positive first. Well, 2x minus 2x, anything minus itself is 0. There's nothing here anymore. That just leaves the 4. And here I have 2x's minus 1x. 2x's minus 1x, that's just going to be x. Oh, I forgot. I miscopied here. Okay, so there we go. So we have figured out that the angle they're talking about is 40 degrees. Now, they didn't ask us for the measure of the complement and the supplement, but they could have. They could have said, what is the angle and what is the complement and what is the supplement? Well, in that case, you would have just come up here and said, well, now I know that x is 40, so you could just put that in, and you'd get that the complement is 50 degrees, and you'd get that the supplement is 140 degrees. So they didn't ask that, but I went ahead and did it anyways. Last problem. So if the sum of three consecutive even integers is 240, what are the three integers? So let's look at the question part, the part we want to zero in right in the beginning. And so consecutive even, that just means it's one after the other, but they're even. So it's not like 1, 2, 3. It's more like 2, 4, 8. So that would be an example. Consecutive even integers, you could say 10, 12, 14. Okay, so something like this. But we need to find three consecutive even integers that add up to 240. So so we know one of them is going to be the smallest, and there's going to be a middle one, and there's going to be a biggest one. So forget these, that was just an example, but I'm immediately going to say I'm going to make x equal the smallest of the numbers. Okay, well, as always, we take the x that we assign to one of the things and we adjust it to accommodate the other things. So how can we, if x is the smallest number, I'll call this the middle number, and I'll call this the biggest number. Okay, well, since they're even, that means they're 2 apart. So the next number has to be 2 more than x. How can I adjust this variable to make an expression that would accurately describe the middle number, the next number after the smallest? Well, it's just going to be 2 more than that. Okay, well, the biggest number, isn't the biggest number going to be 4 more than x? Look up here, the 10, 12, 14. Well, the 10 was 2 bigger than, the 12 was 2 bigger than the 10. The 14 was 4 bigger than the 10. So we could accurately call the biggest number x plus 4. And now, even though we don't know what x is, we have an accurate description that would describe any three consecutive even integers. And it says that the sum is 240, which means all we have to do to make an equation is just add these up. That's the smallest number. We add it to the middle number, and then we add that to the biggest number, and we're going to get 240 when we do that. So now it's just a matter of doing the algebra to solve the equation. We got to get the x's together, and then we need to get x alone. So if I have 1x plus 1x plus 1x, that's 3x, 3x's. If I combine the 2 and the 4, I get 6. Okay, now again, it's all about getting the variable alone. First, I'm going to get rid of this number. I'm going to separate this number off of this. Then I'm going to separate this off of this. So how do I undo having added 6 to this number here, to the 3x? Well, I undo that by subtracting 6, which means I have to do it to both sides. Okay, well now x is some number that was multiplied by 3, but I don't want it to be multiplied by 3. I want to get back to just x alone. How do I undo multiplying by 3? I divide by 3, which means I have to do the same to the other side. And now x is alone, and I know that if I just divide 234 by 3, I'm going to get what x is. And there we go. So x is 80. So we can come up here and we can say we now know the smallest number is 80. We know the middle number is 82. And we know the biggest number is 84. And let's add those up and see if we do indeed get 240. Okay, this is a great example of why you want to check your stuff, because obviously this doesn't add to 240, so we have a careless error, and it looks like this should have been 78. So let's see, this is 78, this would be 80 and 82. Let's try that. 78 plus 80 plus 82, and sure enough, that works. So we have found the 3 consecutive even integers that add up to 240. I hope this helps. Just to sum up, so when you're doing a word problem, do a quick read. Don't be real detailed at first, because you don't really know where you're going yet until you know what they're asking. So do a fast skim. Then once you've done the fast skim, go to the question part and see what exactly do they want me to do here. What are they asking? They're asking for the identity of some number. And then you're going to assign a variable to whatever they're asking. It could be one thing, two things, or three things, but you immediately assign variable expressions to each thing. And then it will become sort of obvious as you think it out a little more what you can do with those to create an equation. You have to create an equation. If you can't find a way to make something equal to something, you have no way to solve the problem. We cannot do math if we can't figure out some way to say something is equal to something. Once you've done that, you've made an equation by saying something's equal to something, then you do your algebraic manipulation to solve, get the variable alone, and that will allow you to get the answer. I hope this helped.